now based off of the information we did yesterday, correct? We know what the domain and the range is based off of the information that we learned yesterday, right? So now what we're going to do is take a look at, and mine looks a little bit different from what yours is, so I'll tell you the changes as we do it. So the domain of the function is y equals 2x. Actually, the domain of the function is all these numbers, and the function is y equals 2x. But before we even get to this, I want you to kind of think about a table of values. So I don't know what grade you were in when you learned about table of values. You learned x and y. You guys maybe called it a t-chart, right? Okay, and we now know that this is our domain and this is our range. Or we can call it x our input or y is our output. We know all those things. So we're going to start with the most basic function you can think of, and that is y equals x. Okay? So we're getting into graphing functions, and you're going to have x's and y's in the same equation. So this equation, y equals x, is as basic as it gets. It means whatever x is, that's what y is too. If x is 0, so is y. If x is -3, so is y. Okay? We're going to eventually get into graphs. You don't have to graph this, but I'm going to show you that -2, -2, 0, 0, or 3, 3. We're going to find out that this graph is y equals x. Okay? So then we're going to take this basic function and change it a little bit. We're going to kind of spice it up a little bit. So instead of taking y just equaling x, we're going to experiment with what y equals 2x looks like. Okay? So you have some different numbers. You can go ahead and just change them right now. Just cross off what's there. So what this means is, first of all, you see this word domain. You have to remember from yesterday what domain means. Is it your x's or your y's? It's your x's. So your domain are these numbers, and so where would I put it? I'm going to put those numbers here, okay? So as soon as it gives you a domain in your graph, in your table, you need to know that they're referring to the x values and that those go here, okay? And then it's going to say, bless you again, here's the domain. If this is your domain, then what's your range? So here's the process we're going to go through to get to that. And we're going to talk about an input-output machine. So maybe just right up here, how many of you have been to the airport and you have been through airport security? Okay, so when you go to airport security, you have to, if you're an adult, take your shoes off, and then you have to put your bag on this little, like, almost like a grocery cart or a grocery conveyor belt. And then it goes into this little machine, right? What is in that machine? It's an x-ray, and there's somebody sitting behind the x-ray machine looking inside, making sure you have nothing unsafe in there, right? And then when it's safe, it kind of comes out the other way. So your bag goes in, they look at it, and then your bag comes out. I want you to keep that in mind as I explain what an input-output table is. So we know that our x values are our input. So if I were to say my input is -2, so I'm going to input -2 onto this little conveyor belt. And when it's in there, it's going to take the place of x in my function that was given. Couldn't write any smaller here, could I? And so then after I take that x, I multiply it by 2. What spits out the other end? Not -2 anymore, -4. So when I inputted, if that's a word, -2, -4 was my resulting output. Does that make sense? So it's kind of like this fancy machine. A lot goes on under this curtain. It multiplies by whatever x was. So I want you to look at how that affects my table of values. I inputted a -2, and I outputted a -4. This table of values is kind of this little in-between part is a spot for you to show your work. I'm not going to include that in every table of values. Okay, it's just kind of showing that these calculations are done, and eventually they can be done in your head. And so now I found my first range value. Now I got to do that same thing for -1, 0, 1, and 2. Okay? So if my y value is going to be 2 times whatever my x value is, then this time my resulting y value is -2 and so on. So 2 times this, y is equal to, and I know you guys can do this in your head, but for right now, so this is 0, this is 1, this is 2. So when I input these, I get my output. Okay, and you don't really need to put y equals for each of them. So now, we're not done. Because this says, and listen to all this math vocab going on here. The function y equals 2x has a domain of all these numbers. And when I input this domain, the output is my range. I just said like every math vocab that we've learned so far, right? Okay? So the resulting range of this function would be -4, -2, 0, 2, and 4, right? So -4, -2, 0, 2, and 4. That is going to be your range because that's what was outputted. So you're going to put R equals and then list your new range. So doesn't your range depend on what your domain is? In other words, doesn't your output depend on what you input? That's why it's called a dependent variable. Okay? So I want you to really kind of start to think about what this means right here. This is a really, really simplified way of saying that, hey guys, every single y value is basically just whatever the x value is times 2. You get that, right? Okay? Because I want you to look right here. If the x value is -2 and now it's -4, didn't I just multiply by 2? If it was -1, now it's -2, didn't I just multiply by 2, right? So why am I showing you this? Because on the flip side, guess what? Here we have a bunch of blank tables in the equation. If we flip this over, you're going to have a bunch of tables already filled in that you need to pull the equation out of. So that's the flip side of this. So are you kind of following us here? All right, let's take a look at this next one. The domain of this function, we're keeping it the same, and that goes here. So you have to know right off the bat that your domain is your x values. So we're sticking with -2, -1, 0, 1, 2. Here's a spot for me to show my work. Whatever yours says, erase it and make it match mine. I think I have a 5 there. Yep, so go ahead and erase that. So my y value this time is going to be whatever my x value is with 3 added to it. So take your x value, which is -2 and -1, add 3 to it. So go ahead and fill out what your range would be as I'm doing this. So -2 with 3 added to it is +1. This is +2, 0 plus 3, 1 plus 3, and 0. Oh, yeah, I said 0 plus 3, and I swear I know how to do my math. That's usually 0, 0. Okay, guess what? And then 2 plus 3 is going to be what? All right, so we're seeing a little bit of a pattern here. That's not always going to happen, but it will when your x values are increasing by the same amount, okay? So now what is the range of this function? It's basically 1, 2, 3, 4, and 5. So listen to this. The y value is basically whatever the x value is with 3 added to it. That's basically the result of that function, okay? This last one gets a little tricky, all right? So you're doing 2 things. So the domain of the function, we have a different domain, and I want you to see in a minute if you can figure out why I chose my domain up for this. Look at the function that I'm asking you to do. I'm asking you to place those values in for x and multiply it by a half. Multiplying by half means divide it by 2. What kind of numbers do you want to divide by 2? Evens or odds? Evens. So instead of -2, -1, 0, 1, 2, I chose -4, -2, 0, 2, 4. That is a really good domain. That is a good domain because you get a couple negatives, a couple positives, and 0. It's going to give you a really good look on the graph. So I changed my domain up a little bit, and I adjusted it to what I need it for. And so now I'm going to take half of -4, which is -2, and then add 3 to it. So it's half of -4 plus 2 is that's going to be what? +1. I'm going to take, so this is -2 plus 3. What's half of -2? -1. Add 3 to that. What's half of, it's going to look like the same domain or range as the other one. What's half of 0? 0. 0 plus 3 more. Half of 2. Oops. And then half of 4 is 2 plus the 3 is 5. Okay, total coincidence that I should have just changed that number probably to 2 or something, but that's okay because your range is just 1, 2, 3, 4, and 5. Okay, so regardless of what type of function I give you, will you be able to take the x's, put it in there, and solve for y? Ultimately, that's what you need to do. So if I give you the function says y equals 0.5x plus 2 divided by 3, could you solve that? Yeah, that's a pretty simple calculation, right? I mean, it's going to stink if the domain I give you is an odd number, but let's say 6. Let's say my domain has just one number in it, and it's 6. What would the range be if your domain is 6? I need you to know this vocab. If this is a question that says, if your domain is 6, what's your range? You'll be like, I don't know. Oh, domain is x. So I'm going to take half of 6, which is 3. I'm going to add 2 to it and get 5. And then I'm going to take 5 and divide it by 3. So my range is going to be 1 and 2/3 or 1.6 repeating. Yep. So, do you follow how to find a range when you're given a domain? By using a table of values. Perfect, okay? So